Hello, everyone. Welcome back to Exploring the Coast with Hannah. On this week's episode in our climate change series, we're going to be looking at marine heat waves on the California coast. Let's go. What is a marine heat wave? Marine heat waves are defined as periods of extreme sea surface temperature persisting for days to months. A strong El Niño event developed in the equatorial Pacific in 2015, with warm water spreading poleward into the northeast Pacific. The combination of these events in the California current large marine ecosystem during 2014 to 2016 led to persistent sea surface temperature anomalies that were often 2 to 4 degrees Celsius above mean climatological values. So what exactly does El Niño and La Niña mean? El Niño and La Niña are opposite phases of what is known as the El Niño Southern Oscillation Cycle. The ENSO cycle is a scientific term that describes the fluctuations in temperature between the ocean and atmosphere in the east central equatorial Pacific. El Niño refers to the large-scale ocean-atmosphere climate interaction linked to a periodic warming in sea surface temperatures across the central and east central equatorial Pacific. La Niña refers to periods of below-average sea surface temperatures, known as the cold phase, across the east central equatorial Pacific. Global climate La Niña impacts tend to be opposite those of El Niño impacts. The cause of marine heat waves are tied to the effects of climate change, which include rising sea surface temperatures, shift in ocean currents due to rising sea surface temperatures, and warming atmospheric temperatures due to greenhouse gas emissions. During 2014 to 2016, the Northeast Pacific experienced an unprecedented period of anomalously warm water, which was referred to as the blob. It has been characterized as the largest marine heat wave recorded in history in the past 40 years. In 2019, there was a new marine heat wave that was forming to blob status of the previous marine heat wave from 2014 to 2016. It's still being monitored now in 2020, but is still holding offshore due to cold water upwelling since it is a La Niña year. Just like in our sea surface temperature and southern species migration video, there are species that help indicate the changes due to marine heat waves. Here we are going to look at the Hopkins rose nudibranch and the owl limpet. We first learned about the Hopkins rose nudibranch in our first climate change video as a species that has migrated northward up the west coast due to the rising of sea surface temperatures. This species is also an indicator of marine heat waves in that their populations bloom during these events, including the 2014 to 2016 marine heat wave. They were observed in high abundances at many sites throughout Northern California. While these nudibranchs still remain here after marine heat waves in less numbers due to an overall increase of sea surface temperatures, scientists believe a possible outcome of the blooms is that warmer water and increased larval transport from lower latitudes may establish or sustain marginal or sink populations that can persist indefinitely. Similar to the Hopkins rose nudibranch, scientists also saw a large increase in abundance and larval recruitment of owl limpets in Northern California, going from Bodega Marine Reserve to Crescent City, which, if you remembered from our first video on climate change, it is a species whose previous distribution only went northward as far as San Francisco. Here's a graph that shows the increase in abundance and larval recruitment of owl limpets following the marine heat wave at Bodega Marine Reserve, California. In 2010, only larger size classes of owl limpets were present at the Bodega Marine Reserve, with no evidence of recent recruitment of smaller individuals. By June 2016, scientists recorded a striking increase in recruitment of juvenile owl limpets. By May 2017, many of these owl limpets had grown into larger size classes. Also, in May 2017, a second large group of small 15 to 35 millimeter owl limpets were apparent. In May 2018, limpets from the 2 years of successful recruitment from late 2014 and late 2015 continued to grow into larger size classes, being 30 to 55 millimeters long. So what were some of the major impacts of marine heat waves occurring on the California coast? They included species die-offs, limited food availability and food web disruption, fishery closures, and also threats to human health. The large species die-off and strandings due to the 2014-2016 marine heat wave included a large common murre die-off that believed to have reached up to approximately 1 million birds from summer 2015 to spring 2016. In 2015, a large whale unusual mortality event, also known as a UME, that consisted of fin and humpback whales occurred along the coasts of Alaska and British Columbia. During this time, it also left some 4,000 stranded California sea lions due to starvation. Due to the increase of sea surface temperatures during the marine heat wave, it caused a major disruption in marine food webs. These disruptions included limiting key food sources for many marine species, causing starvation, like the emaciated seal pup picture on the left-hand side. It also caused an increase in less desirable food species like pyrosomes, which are pictured on the right. It also caused key species like sardines to move further offshore, causing other species to travel longer distances to obtain food. Marine heat waves also greatly impact fisheries. During the 2014-2016 marine heat wave, it caused Dungeness crab and clam fisheries to close. Anchovy and sardine fisheries were also greatly impacted due to harmful algal blooms. It also caused a significant decline in krill, cod, and salmon populations as well. Marine heat waves not only affect marine life, but they also pose a threat to human health as well. They can cause what is known as harmful algal blooms, or HABs. Harmful algal blooms are when there is a large increase in algal population growth. These occur seasonally due to an increase in sea surface temperatures, but in a marine heat wave, it is exacerbated, which causes death in many marine species and also can affect humans who eat contaminated crustaceans or fishes, which is known as shellfish poisoning and can cause respiratory and gastrointestinal problems, and in some cases can even be fatal. As sea surface temperatures and greenhouse gas emissions continue to rise, we could see prolonged marine heat waves and enhanced poleward dispersal that can play an important role in longer-term shifts in the composition of coastal communities in Northern California and other biogeographical transition zones. Thanks so much for joining me today. The next video of Exploring the Coast with Hannah drops Tuesday, July 21st at 11 a.m. on the Pacific Grove Museum of Natural History's Museum to You page.